Alright, and sometimes when you're trying to simplify these expressions, you need to simplify or break down each radical first before you can start trying to combine things together, and that's the case with this problem. So we're going to look at each one of these radicals in the problem individually and see if we can't simplify them down some. So if we look at 54, again, the whole point is to try to find a perfect square that goes evenly into 54, and preferably the largest one that does. And the largest one that goes evenly into 54 is 9, so I'm going to break that into 9 times 6. And I'm just going to kind of write out all of these, how I'm going to break them down, and then break them down in the next step. So if I move on to this 20, the largest perfect square that goes into 20 is 4. So I've got 4 times 5. The largest perfect square that goes into 45 is again 9, so that's going to break down into 9 times 5. And then the largest perfect square that goes into 24 is again 4, which breaks down into 4 times 6. Okay, and so now I can break these radicals into their pieces. So I've got 2 times the square root of 9 times the square root of 6 minus the square root of 4 times the square root of 5 plus the square root of 9 times the square root of 5 minus the square root of 4 times the square root of 6. Okay, and so all of these perfect squares, the 9s and the 4s, I'm going to break those down into their whole numbers and get rid of those radicals. So the square root of 9 is just 3, so this now becomes 2 times 3 times the square root of 6. This now becomes 2 times the square root of 5. This now becomes 3 times the square root of 5. And this last one now becomes 2 times the square root of 6. Okay, so out here, this front one is the only one where we had a constant out in front to begin with, so don't lose it, don't forget about it. That is important to the problem. So this is now 2 times 3, which is 6, obviously. So we've got 6 times the square root of 6 minus 2 times the square root of 5 plus 3 times the square root of 5 minus 2 times the square root of 6. So again, related to the last problem we did, we're going to combine together the terms that have the same radicals, which will be these two in the middle. We'll be able to combine those together, and then the first one and the last one, because they have the same numbers underneath their radicals. So I've got 6 root 6 minus 2 root 6, which gives us 4 root 6. Because again, kind of treat that radical like a variable. It doesn't really change when you do addition and subtraction. It's only the coefficients out in front that will change. And then we've got a negative 2 to the negative 2 times the square root of 5 plus 3 times the square root of 5. So we've got a negative 2 plus 3 that will give us a plus 1. And you can either put that 1 out in front or not. It doesn't matter. You could just have written that as plus the square root of 5. But we'll leave the 1 out there just to illustrate. Please let me know if you have any questions.